Okay, so in this question we are given a formula for the surface area of a cylinder A, and it's in terms of x, and then we are told something about the rate of change of the area with respect to the radius. Well, basically that means the dA by dx, okay, the rate of change of A with respect to x. So the first job we need to do is just simply to differentiate that formula. Okay, so if we just jot it down, we've got A equals 2 pi x squared plus 2000 over x. Before we differentiate, because we've got this little x sitting on the bottom, it might be worth rewriting it using index notation, and so we can say, well, that in fact equals, yes, 2 pi x squared, but let's rewrite this one as 2000 x to the minus 1. Okay, and now we do our differentiation as normal, and we say, well, the rate of change of area with respect to the radius x, or dA by dx. Then we'll just differentiate the x's, so times by 2, so we get 4 pi x, and sorry, jumping to this one, minus 1 times 2000, drop the power, and that gives us the differentiated function. Okay, now back to the question. It said when the rate of change of the area is 0, then we're supposed to sort of show something. So let's have a look what we've got. For the rate of change, we've got this expression here, so we're going to make it equal to 0. So we're going to say, alright, well, 4 pi x minus 2000 x to the minus 2 is prettier, written that like that. When that equals 0, let's see what happens if we just clean it up a bit. So what we'll do is we'll shift this across to get something like that, and then whenever we simplify, if we had x's in the denominator, we'd multiply through just to clean it up. So let's do that. Multiply through by x squared, we get 4 pi x cubed equals 2000. Well, this is already looking promising, because if you remember, it said something about show that x cubed is blah blah blah. Well, here's our x cubed, so all we need to do is make that the subject. X cubed equals 2000 over 4 pi, divide through by 4, top and bottom, and guess what? 500 over pi. Job done. Okay? So it's really just a matter of, when you see that talk of rate of change, to know that you're meant to differentiate. Once you differentiate, you're told that that rate is equal to 0. So I just made that result equal to 0. A little bit of rearranging to make the subject be what they were asking for in the question, and I think we're there.